Good evening. I'm Jeff Jalkio with the University of St. Thomas Physics Department. And on behalf of the Science and Theology Network, I'd like to welcome you to tonight's event on ecotheology and climate change. The mission of the Science and Theology Network is to create forums like this that highlight the interactions between science and theology. We offer public lectures, reading groups, and special events through the year. And we're very happy that you've decided to join us tonight for this event, the first of 2021. We have two speakers who will be looking at ecological issues from the standpoint of different professional backgrounds. John Abraham is a thermal scientist who has studied climate change issues at length. And Alan Padgett is a theologian who has worked in the field of ecotheology. I've happened to hear them both speak in the past, and so I think you're in for a real treat. We'll have time for questions after each speaker's presentation, so feel free to post your questions using the Q&A button that you'll find at the bottom of your Zoom screen. We ask that you refrain from using the chat function, and we want to reserve that for technical problems that you might encounter, but hopefully there won't be any of those tonight. Our first speaker tonight is Alan Padgett, who will speak to the question, what is ecotheology and why does it matter? Alan is a philosopher, a theologian, an ordained minister, and a prolific author. He graduated from Drew University with a master's degree in divinity, and after serving full-time in pastoral ministry, he received a doctorate in philosophy from the University of Oxford. He's currently a professor of systematic theology at Luther Seminary here in Minnesota, where he teaches courses in Christian theology and ethics. He is author, editor, and co-author of 12 books and over 100 academic essays, and is known for his work at the intersection of theology, biblical studies, philosophy, and the sciences, as well as his contributions to Christian theology, philosophy of religion, and systematic theology. His most recent work, which is quite relevant to our talk tonight, is Ecotheology, a Christian Conversation, which he co-edited with Chiara Jorgensen. So I think with that, we will go ahead and show you Alan's presentation.
Hi, my name's Alan Padgett. I teach theology at Luther Seminary. I've got a lifelong interest in theology and the sciences. And what I've been noticing over time actually is more and more, although my own background is more in physics, astronomy, mathematics, it's really the biological sciences that have been pushing a lot of the issues for the Christian church, whether it's evolution, genetic technology, and engineering, or as our conference is about, the environment and ecotheology, and issues especially of climate change. So I was my privilege to be involved in a book project that was recently been published, Ecotheology, a Christian Conversation, which I co-edited with Chiara Jorgensen. And there's also a contribution by a climate scientist, Catherine Hayhoe, in the beginning, that if you want to read more about the scientific reasons for the acceptance not only of accelerated global warming as a genuine reality that we're experiencing, but that humans are involved. And one of the major causes of the acceleration of climate change in our time is what humans have been doing over the generations to our planet. It doesn't take a lot of thinking and reading and learning to recognize that our planet is in trouble. And the Christian church already, starting in the 1950s, the theologians have been trying to overcome what is in fact an unfortunate theological focus in the past on the soul to the detriment of the body, and on human beings to the detriment of the rest of creation. And what some of us have been able to discover is that actually the scriptures themselves are not nearly as focused on the soul and on human salvation alone, apart from the earth, as we've been taught by our tradition. So ecotheology then, in a nutshell, I guess, is this attempt to rethink and revisit the classic Christian tradition in theology, including moral theology and Christian ethics, to account for the fact that really it's wrong of us to think of theology as primarily about, getting out of hell and going to heaven, as if the whole of the message of the gospel is some kind of fire insurance, and instead to recognize the holistic teachings of the Christian faith, read holistically and interpreted that way. So that's been a major project of mine for a while now, and I think that I've been really pleased to discover that, along with many other important scholars who know a lot more about the Bible than I do, that the Bible itself and our Holy Scripture as Christians is much more earth-friendly and creature-friendly and connects human beings much more fully with the earth than our classic Christian tradition has actually been teaching us. Of course, I'm not talking about the creeds, and the great councils of the church, but many of our theologians have overemphasized salvation of the individual and the soul in a way that has contributed to the current crisis and a lot of the conflict and debate within the churches themselves. So it's the task of ecotheology then, as a theological enterprise, to argue that no, all along, all the way back to the scriptures themselves, the God of salvation is also the God of creation and the God of all creatures. So in this very short little lecture, I'm going to go over a few topics in biblical interpretation and the theological and moral interpretation of the Bible, a few topics in systematic theology, and just a few things in Christian ethics. Really, this is just the tip of the iceberg of what I think of as a fascinating literature, debate, discussion that's going on in our times. It's fascinating, but it's also essential in many ways, because these ideas are important to get into the churches, into sermons, into the teachings of all congregations and all people of this earth. It's wonderful that the Holy Father, Pope Francis I, published that great encyclical Laudatio Si on the care of our common home, the planet Earth. That's a fantastic resource that I would recommend any of you to read if you haven't read that yet. It's really excellent. And there's so many more other good things to think about. Well, if we could begin to thinking something about Christian theology, then we're going to be asking the question, who is God? And what is God like? And in ecotheology, in a Christian ecotheology, God is understood as the creator of all things. And that the world as a whole is God's creation. Nature, then, if you ask what is nature, what is the creation? This is a system of life whose purpose is flourishing and growing. If you look at Genesis 1, the classic Christian text on creation is Genesis 1 and 2. If you look at Genesis 1, God creates the whole universe. God doesn't just create humans. In fact, humans don't even have their own day. We're part of God's creation of all the environments, and then in the first 3 days, and God creates the beings that inhabit those environments. I have to say that because God also creates the sun, moon, and stars and puts them in the light and in the night, that created in day one. But, so the living creatures, too, are placed in the air and in the ocean and on the land. And humans on the sixth day are put in with all the other land animals. We don't get our own day. There's a community here that's implied of all land animals, and humans are just a part of that. So part of the reinterpretation of the scriptures is beginning to see that God is the God of all creatures and of all creation. And that God didn't just create in the beginning, but God is involved in the creation and in the creatures over time in order to provide environments and fundamental bases for life to flourish and grow and be abundant. Remember, there's a command to all the creatures to be fruitful and multiply, so that abundance, fruitfulness, vitality is God's own value as creator. And the doctrine of providence is also being rethought because there's been this tendency since St. Augustine of Hippo in North Africa to focus providence on human beings and on salvation. But biblically, the fact that God provides, which is, providence is just talking about God as providing, the fact that God provides is fundamentally grounded in all creation. So if you look, for example, at that beautiful Psalm 104, this is being rediscovered as a key text among many texts in the Bible, grounding divine providence in all creation, and only then secondarily to humans, and in the face of sin, leading to the need to redeem human beings. So I'll just share a little bit. Psalm 104 is really beautiful, and you should just go read it when you're done with this conference. But God makes springs pour water into ravines. It flows between the mountains. They give water to all the beasts of the field. The wild asses quench their thirst. The birds of the sky nest by the waters. They sing among the branches. He hears the mountains from his upper chambers and waters them. The land is satisfied by the fruit of God's work. So here you're saying that it is God who's at work through the systems of creation itself to make life possible and to make it diverse and vital. It doesn't take a lot of thinking to connect this theological emphasis on God's own focus on life and making life possible, abundant, and blessed with the need to develop and keep diversity in our biosystems and have vibrant species diversification and other things that we're learning scientifically are so key to this abundance and this blessedness of that is life itself. So you can see that this is a real shift from earlier focus on providence as the salvation of the human being from sin and death to providence as providing for all creatures, humans included. So when it comes to thinking about the place of humans in reality and in creation, there's also been a fundamental rethinking theologically and in terms of understanding Scripture. Humans are no longer sought to be elevated as somehow unique, separate, different from all other creatures. The soul is not thought of as some essentially immortal thing, but that rather, like all other creatures, humans die by nature. It's not that we don't have a soul, but, in fact, the Hebrew Bible says that all creatures, all animals have a soul. Yeah, we don't know that. That's often obscured by our translations, but in fact, that's what we've discovered is in the Hebrew Bible, animals have souls as well. So the fact that we have a soul doesn't distinguish us from the other land animals all that much. Rather, what distinguishes us is that God speaks to us, we speak to God, and that we've been given certain commands, we have certain responsibilities and obligations to God, to our neighbor, and to the earth. So just like every animal has a particular function in the larger place of life, the system of life, or as Richard Bauckham beautifully calls it, the community of creation. So all of us then that are human have a particular function, and the Bible has typically been interpreted as if thinking that this is some kind of domination or control over the earth. And in the Enlightenment period in particular, people drew on this Christian idea. Enlightenment thinkers, philosophers, people like Francis Bacon, René Descartes, the new sciences that were then being developed were allowing humans then to penetrate and control and be the lords and masters of nature. And this combination of Christian tradition and Enlightenment, well, let's just call it Enlightenment arrogance about human nature and the powers of science vis-a-vis natural things, has led to tremendous devastation. It's not that all the way back to the invention of agriculture, humans haven't been involved in changing the planet. That's true. But science and technology combined have given humans a capacity to change the earth in accelerated ways that have been devastating to our fellow creatures and to species on our earth. And so it's vital that we begin to rethink these things theologically, that as people of faith, they can have conversations, that can lead discussion. We can talk within our community and circle of faith, just as we can talk with all people of all goodwill all over our planet, as Pope Francis addressed Laudatio Si to not only to Christians and church leaders, but to everyone on our planet. So it's important that we're able to have these conversations and discuss things theologically, not just pragmatically, not just practically, not just scientifically, although those are important too. I'm not discounting those at all, but that also that theologically we can be grounded in an ethic of earth keeping and a humility about how the scriptures talk about humans and the place of humans in God's plan for really all of the earth. There's another fascinating doctrine of eschatology, that is what happens in the future. And what's been discovered, again, fascinatingly, is although many of us think that, we die and then we float off to heaven or whatever, and heaven is this other place that's not at all part of earth, has nothing to do with this planet. In the scriptures, the destiny of humans in the world to come is a new heavens and a new earth. It's not some other planet. It's this planet renewed and restored by God. So that humans and earth belong together, even in the world to come. Even in the resurrection, human beings will be with the earth. We'll be in the community of creation. In Revelation chapter 21, the new heaven and the new earth, there's trees, there's waters. There's going to be an ecosystem in the world to come too, and not just in this world. There's been a rethinking then of some of these key doctrines in terms of systematic theology. The fact that Jesus is the creator of all things, according to many New Testament texts, for example, John chapter 1, Colossians chapter 1, he's all things hold together in Christ, Jesus, the incarnate God, so that all creation, Christ isn't just the God for humans, but Christ is actually bringing about the renewal and restoration of all things. And the creation too has a future in God's plan. And not just the human soul is going to float off and be in heaven or something like that with angels playing harps. That whole tradition really is not actually, not only is it dangerous in a time like ours of climate crisis and ecological devastation and environmental degradation, but it's also just wrong in terms of scripture. That's just not what it says. Well, I've been talking a little bit about some of these discoveries in ecotheology that I find interesting, worthwhile, helpful, you might even say therapeutic for the Christian church. But an important area here has to be about ethics, because no one is going to be involved in ecotheology that doesn't recognize there's an absolutely central concern and need for the human church, the Christian church, and for humans as a whole, to be involved in practical things that can change our planet and help alter the future projections of devastation and death that we're headed for if we don't change things soon. There's really no other way to look at it. The more you learn about what scientists think is happening in all these different areas of the study of our living planet, the more reason there is for concern. But there's also reason for hope. And the hope is because if we understand that God is actually at work in people's lives, in the church, and in all people of goodwill to overcome this harmful ecological crisis that we're in. So we're not doing this all by ourselves, but that the Holy Trinity is working in, through, and with us. And that God has a purpose and a plan and is working that out in the midst of all this. I'm not saying God controls every little detail of people's lives, because I don't believe that theologically, but rather that God has a purpose and God is working with humans to bring that good purpose about, to renew the earth. And just as in Psalm 104, just as in Genesis chapter 1, just as in the teachings of Jesus on the Sermon on the Mount, God is working to bring healing and abundance and vitality to the birds of the air and the lilies of the field. So in terms of Christian ethics, then, ecotheology is again looking not so much at throwing out everything in the tradition and starting all over again, but rather taking our traditional Christian values and systems of thinking ethically and recognizing that these have to be transformed into earth-friendly, eco-friendly understandings of the moral foundations of Christian life. Because the fact of the matter is, when we start getting involved in actual proposing new laws, arguing for different kind of practices, there's often a lot of complex ethical issues going on there. And in moral theology or Christian ethics, what we learn to do is try to tease apart the various moral forces, I call them, like the forces or principles, you have to get a little vague here, that are pulling us in different directions, and seeing if that kind of analysis can help us to see which of these choices is actually morally the best one. Or as often is the case, which one of these is the least harmful and at the same time helps promote the healing that our earth needs and the eco-justice that we are obliged to work for within the community of creation and with our neighbors, the living animals and plants of our planet. So I'll give you some examples. So there's different systems that are the foundation of Christian ethical thinking, right? So one of those is a virtue ethic. So there are theologians that are working hard on talking about a new list, a new listing, and a new understanding of what it means to live a virtuous Christian life that includes care for the earth, that includes humility, that extends the love command to include all living things on our planet as neighbors and not just the human neighbor. I mean, it's hard enough to love the human neighbor, but I agree, I understand that. But in our difficult times, we need to rethink Christian morality in a way that includes the ecosystems. And this needs to be taught and lived. That is not an easy task, any more than bringing peace to our war-fraught world is an easy task. But it's a wonderful and a noble goal. I'll give you one more example, and then I probably need to draw my lecture to a close. But another foundation for Christian ethics besides virtues and looking at the good character is divine command. So, there are these ideas that there are these moral duties that are written down then and come to us as commands of God. And usually the divine command is understood ethically to be fairly general and broad, not so much as a list of rules as of moral principles that can be applied in a variety of different contexts. And so I already mentioned the love command is like by rethinking the love command, the principle of love and the idea of loving your neighbor, not so much a bunch of do's and don'ts or some kind of list, but that the understanding of love as being extended to the world that God also loves and delights in, and not just to our fellow humans. Or think about justice, and being a just person, that's a virtue, but also living a just life and seeking just actions. The earth itself has rights, if we understand rights in a certain way for Christians. One way to understand rights, it goes back to the French philosopher Simone Weil, is to say that rights are one way of talking about the duties and obligations we owe to the neighbor. That is, to say that I have the right of free speech means that the rest of you have a duty and an obligation not to censor me and to listen to me. Allow me my voice to be heard, in other words. And that's especially true of the state, right? The state has a duty and obligation to me of allowing my voice to be heard and not suppressing especially my political speech, my speech about what's going on in the world and what I want the government to do. So if we think about rights then as duties and obligations that communities have to certain individuals or things, then there's no reason not to think that the earth itself has rights. Rights that are given to it by God. Rights to being abundant. Rights to being allowed to be fruitful and blessed and vital and alive. And this brings joy to the Creator. It's very clear from Scripture. So, I mean, here's two fundamental, moral principles that are grounded in who God is and are communicated in divine command. That is love and justice. And eco-theologians that are rethinking what this means for a world in crisis, a living planet that's in crisis. Well, you can see that I'm really interested in this topic. We could go on a long time, but we want to also have time not only to learn from the scientific perspective from Professor Abram, but also to have conversation with each other. So thank you for listening. God bless you. Happy Earth Day. Happy Easter. And we'll talk again.
That's good. So, Alan, we have a few questions from the audience.
Oh, great. Excellent.
And I'd like to just ask those on their behalf. So first of all, first question that came in is, any idea why the theological focus had been on salvation and is now shifting to other things?
Oh, no, that's actually an excellent question. And I think that to be fair, the Bible is written by humans for humans, and there is a definite focus on humanity in Scripture because behind those human authors, I believe, is God, the Holy Spirit, directing them to give us needed divine revelation so that we can have a better relationship with God and live better lives and become all that God wants the human race to become. But I think what happened was an over-narrowing over time on the soul. And part of that was the Platonic tradition that Christianity grew up in and absorbed as the closest philosophical and scientific understanding of the world to Christian values and to that same divine revelation. But unfortunately, in Platonism, Christian Platonism included, what's really important is the soul, the mind, and so that's the highest thing. That got to be called the most important thing in us, the highest thing, the one thing that really mattered. And the body was secondary. There was really a whole system of varieties of different kinds of Hellenistic dualism, and by dualism in that ancient classical sense, I mean that the spiritual, the eternal, the mental is valued, and the physical is seen as less valuable, or even in many kinds of Hellenistic dualism, for example, Gnosticism, actually harmful and negative. And already in the Corinthian letters, Paul has to fight against this idea that that the body is bad, that we should only eat vegetables because meat and blood are bad things, or that sexual intercourse and procreation are somehow, not very spiritual. And so we see these kinds of influences coming into what is really a more earth-friendly, more creation-friendly scriptures, especially the Hebrew Bible, or what we Christians call the Old Testament. And so I think that I'm not against the idea that salvation really matters. I'm not trying to say that, but I want to say that, overcoming that the influence of that Hellenistic dualism has been at work. It started somewhat in the Reformation, but I think as what's happened is the climate crisis that we've been discovering in our own era has made theologians go back and really examine this again in new ways and ask, is this an appropriate tradition? Is this something that we want to keep, as part of the Christian identity over time? Or is this something that made a lot of sense in a certain time and entered into our thinking for 1,000 years or so? Theology's been around a while. And that now we really need to re-examine that. And so there's been a lot of work on that. I think some of the early work by feminist scholars too noticed that, the body and procreation were downplayed as not particularly spiritual, that the real spiritual people are celibate and don't get involved in those bloody, messy things. And so they also, around the same time, and talk about the mid-20th century, were calling this into question. So those two streams, I think, are the reason that we've been re-examining this for the last, not quite 100 years, less than 100 years. But I think real progress has been made so that you can say, hey, look, I'm Orthodox, I want to be biblical, but I don't want to focus everything on the human soul. I think that's actually not biblical and historic, the Christian faith. We need to peel that away a little bit. I love Plato and Aristotle. I think they're awesome philosophers, but I think that influence of Hellenistic dualism has been unfortunate in its devaluation of the creation that God has made. Genesis is not afraid of the physicalness. Humans are made out of mud. I mean, there's no concern there for the materiality of human existence in the way that gets developed in the Christian tradition as it grows into the Hellenistic culture of the Roman Empire.
Well, here's
I hope that
another.
wasn't too long.
Oh, no, it's wonderful. Here's another question that came in. The huge modern human technosphere is based on fossil fuels and is driving climate change. And fossil fuels are not easily replaced by energy alternatives. So the virtue of modest consumption, even voluntary poverty, should be at the top of the list of virtues. Why does modest consumption not top your list of virtues?
Well, I don't know that list. My own view of the virtues is there is no top and there is no bottom. I mean, but rather that there are fundamental principles that order all the virtues. And for the Christian tradition, those principles are love and justice. And so that all of the virtues then are ordered by love and justice. And, so that, and then you ask, well, which is the most important one? That's very contextual, So it may be that I'm already living a very humble, this is actually false, of course, but I'm already living a very humble life. And for me, I need to focus on a different virtue, maybe silence or something like that. So that what the virtue that's most important for American culture probably, I think, is the virtue of humility and the virtue of abandoning wealth, poverty, right? And avoiding pleasure in favor of loving the neighbor instead. I mean, so there are important virtues that you could say, well, the current American culture really needs to hear this. But in terms of moral theology, that is the theory of Christian ethics and the theory of Christian virtue ethics, there are very high level principles of love and justice. And it's those that order and structure and give meaning to the virtues. The other thing you need in a virtue ethic, this is just an aside, not direct answer, is like a good story or a good history of someone who actually embodied these virtues so that we can see how it works. And so that's why the Christian moral ideal in terms of virtues is Jesus himself. And so we can certainly see the virtue you want to see active regularly in the life of Jesus, absolutely, all the way back to the incarnation itself and the self-emptying of God and to be born in the Virgin's womb. So I'm not downplaying the importance of that virtue at all. I'm just saying, in theory, what orders and structures the virtues is love and justice, and that what virtues at the top or whatever, there's a lot of debate about that, but that tends to be a contextual issue. Like what do we need to hear in our time and in our culture?
Thank you. So another question that
question.
came up
Excellent.
here is, have Christian churches ever been against caring for the earth, or are we really just talking about a change in focus?
I think what's happened is that caring for the earth has kind of dropped out. It's benign neglect. It's not that anyone was ever against caring for the earth. I mean, you have to remember, St. Francis is the patron saint. He's medieval, right? Patron saint of creation care. He's medieval. But it's not that they've been against care for the earth. It's just in the busyness of life, and you look at sermons and what people were actually concerned about and how people were trying to work to bring renewal to the church. Somebody like John Wesley maybe trying to renew the church and revitalize it. Or you look at the monastic movements and their attempt to revitalize the church. Or you look at the Catholic reformers like John of the Cross, Teresa of Avila. Care for the earth just isn't real big on their list of important things we have to worry about. It's not that they were against it, and so I think what's happened is we've gone back and said, whoa, this is really, really important. We've just forgot to bring it into the list and make it a central part of the way we live as Christians in the world today. So I don't, it wasn't so much that the church is against it, just more benign neglect. It's like we just didn't really emphasize it like we should have, perhaps.
Okay. Another attendee asked, what specifically did you find valuable in Pope Francis's document that you referenced?
Oh, I love that thing. And the reason is, it's such a beautiful, first of all, it's an encyclical, right? So classically, an encyclical is supposed to be written to bishops, right? This is written to all people of goodwill on the whole planet Earth. They're like, whoa, okay. And it draws on scripture, it draws on tradition, it draws on very good science, It blends them all together in this beautifully clear, and then it grounds it in the great St. Francis. It's like, theology doesn't get better than that. That's just beautiful stuff. And yet, anybody that wants to sit down and really study it can understand it. It's not so turgid and difficult and complex that you don't get what's going on. And the other thing is it majors on the majors. I mean, it touches on the major important things, and it brings in issues of poverty and other global issues that we're dealing with and integrates them all in this beautiful, organic way. It's really good. It's just good. It's solid, excellent global theology. It's hard to, if anything I wrote was anywhere near that good, I'd be extremely pleased. Of course, the fact that it comes from, the leader of over a billion Christians around the world, that helps. So there's a lot of Catholics on this planet. And Francis speaks for a lot of Christians, I think, in focusing on that. So I don't think you have to be Roman Catholic to think it's really good. I just think it is really good.
Well, thank you, Alan, and I want to thank everyone who asked questions. We will have time for additional questions at the end of tonight's program, but I want to move along and make sure we have time for John's presentation. So let me go ahead and introduce John, if I may. So Alan, if you could join us when we come back with questions. So John Abraham is our next speaker, and he's here to warn us that this is not the climate your grandparents grew up with. John is a professor in the School of Engineering here at the University of St. Thomas, who is known worldwide for his work on climate change. His BS, master's, and PhD degrees are from the University of Minnesota, and he has produced approximately 350 publications. He doesn't look that old. And those include peer-reviewed journals, journal articles, books, book chapters, patents, and conference presentations. In addition to his work on climate change, he has published widely in the fields of heat transfer and thermal sciences, as well as renewable energy generation for the developing world. He is the co-inventor of a technology that provides clean drinking water to impoverished communities around the world, and has installed solar power in villages in Africa. I would like to present John Abraham.
Well, Jeff, it's a great pleasure to participate in this. And I have to tell you, I've got a couple problems. One, the name Katharine Hayhoe has been mentioned by Alan. And if you go to Katharine's a friend of mine. And if you go to Katharine Hayhoe's Wikipedia page, you'll find a quote from me calling her the greatest climate science communicator in the world. And I stand by that. But anytime you appear in any presentation after the name Katharine Hayhoe is mentioned, you feel inadequate. The other reason why I'm a little bit nervous is I have to follow that eloquent talk by Alan by talking about science. Who wants to talk about science? Science sounds like it's like a visit to the doctor, but I'm going to make a promise to you that this is going to be short and sweet, and it's going to be like going to get your COVID vaccine. It might hurt a little, but it's going to feel really, really good. So I'm going to give a brief introduction about the science of climate change. I'm going to go relatively quickly through this, and I hope it's intelligible. And then we'll come out the other side and handle questions. And I'm presuming people can see my computer screen. And if not, let me know. But I'm going to get right into it. So the first thing I want to start out is, what are the things we know? What are the things that scientists know? Here are some unequivocal facts. One, warming is unequivocal. We know the Earth is warming. We know that each of the last 3, and actually now 4 decades was warmer than the prior decade. We know that extreme weather is increasing. We know that Greenland and Antarctica and other places are losing ice.
John, you're not sharing your screen yet.
It's not sharing my screen?
No.
Okay, let me try that again. Can you see my screen?
Excellent.
Okay, so I'm going to go through the things that we know, and I apologize for that hiccup. It won't cost us much time, but here are the things that we know. As I mentioned before, warming is unequivocal. Each of the last decades has been warmer than the prior decade. Extreme weather is increasing. We're losing ice. We're losing snowfall. Sea levels are rising. The North and South Pole are warming. Glacier ice is happening. Ice loss is happening. And the ocean is changing its chemistry. It's becoming more acidic. Those are the things that we know. And about 97% of the world's climate scientists connect these dots. These are things that are all related to each other. And the vast, vast majority of scientists, and now the vast majority of the general public, understand that these things are connected to each other. I like to start out with this slide, which is a photograph of a child holding a globe. And this photograph means a lot to me because of the color of the skin of this child and also the part of the globe that is facing the photographer. When we think about climate change, we have to think about social equity, and we have to think about the fact that some societies have built their infrastructure and economy on fossil fuels, and that is going to raise more havoc in other economies that are less responsible for climate change. All humans are contributing to climate change, but some more than others. And we are looking at the continent of Africa, which has got large areas of subsistence farming. And we're looking at the skin color of someone who is a descendant from Africa. And this just speaks to us. I hope it speaks to us. It does speak to me about the importance of acknowledging that we're all in this together, but there is a social equity piece that we want to acknowledge. All right, so I listed a bunch of things that were facts. Now, why do climate scientists say they're all connected? Why do climate scientists say that humans are the cause of what we're seeing? It's not just that we're seeing warming. It's that we're seeing warming with human fingerprints on it, just like a crime scene. Fingerprints can tell you the perpetrator. We have fingerprints in the climate. And let me give you just a couple examples from this slide. Sometimes people say, hey, John, the sun is getting hotter. That's what's causing global warming. Well, that's something that we could test. If the sun was the cause of our warming, then we would expect daytimes to warm more than nights because that's when the sun shines. And we would also expect the tropics to warm, where you get more sunshine, to warm more than the poles. In addition, you would expect the entire atmosphere to be getting warmer from the top down to the bottom. We're observing none of those things. We're observing nights warming faster than days. We're observing the poles getting warmer faster than where most of the sunlight is, the tropics. And we're observing the upper part of the atmosphere actually getting colder than the lower part. And that's because we're holding heat down with greenhouse gases. So when scientists talk about their certainty of climate change and human influence on climate change, it's not just because the climate's changing. It's changing in the way we expect it to if humans were the cause. A very brief intro of what the greenhouse effect is. This is a little cartoon that shows the sun. Sun rays pass toward the earth, causes daylight. We love it. Sunlight goes through the atmosphere. And in fact, our atmosphere is transparent to sunlight. Sunlight passes through the atmosphere. The earth warms up because of this sunlight and sends out its own heat, which is not sunlight. It's called infrared heat. And the atmosphere is able to block the outgoing energy. And the atmosphere sends that energy back. That is the greenhouse effect in a nutshell. And it's not, the key issue isn't that there is a greenhouse effect. There would be a greenhouse effect even if there were no humans on the planet. Rather, the important thing is what happens if we make the greenhouse effect stronger? What happens if the atmosphere sends more heat back to the earth than it used to? And that's the thing that scientists are concerned about. You're looking at a graph that is one of the most famous graphs in all of climate scientists. And my wife always tells me, every time you show a graph, half of the people go to sleep. That's not going to happen today. And there's not going to be that many graphs. But this graph is called the Keeling curve, named after Charles David Keeling. And it shows carbon dioxide levels from 1958 to 2021. And the carbon dioxide levels are shown by that bumpy red curve. And every year you get an up and down in the carbon dioxide level, but each year that up and down gets higher. And so what I want you to look at is the black line. The black line shows the long-term trend of carbon dioxide. Before 1958, we were at about 315 parts per million. That means if you took a million molecules out of the atmosphere, 315 would be carbon dioxide. And now we're at almost 420. So that's a significant increase in carbon dioxide. The increase that you see on this slide is entirely human driven, period. It's not just carbon dioxide that we're concerned about. There are other greenhouse gases. You've probably heard of methane and nitrous oxide and other greenhouse gases. This is a graph that goes back to the year zero. On the left-hand side of the graph are the greenhouse gas levels year zero. On the right-hand side of the graph are the greenhouse gas levels the year 2000. And what I want you to notice is that all three of those greenhouse gases start to rise precipitously approximately the 1700s to 1800s, or the onset of the Industrial Revolution. So carbon dioxide is the most important greenhouse gas, but there are also other greenhouse gases that truly matter, and they are all rising in lockstep. All right, so the first question to your mind might be, so what, John? Who cares? Who cares if we have more greenhouse gases in the atmosphere? Is that causing a temperature rise? Well, this plot here shows you the Earth temperatures each year, measured by NASA. On the left-hand side of the graph are the temperatures at 1880, and on the right-hand side are the temperatures through 2022. Each black dot is a given year temperature. And what we do is we average the temperatures throughout the entire year across the entire planet. And just like weather will go up and down, up and down, up and down. Tomorrow might be warmer than today. Yesterday might have been warmer or colder than today. We get this natural fluctuation. What scientists want to know is there a long-term trend? Is there a trend of the data? And clearly there is a trend. Clearly it is getting hotter. And I'm going to show you the hottest years in order ever recorded by humans on planet Earth. Hottest year ever, 2016. And these are the rest. I think I'm going to show you the top 13. Those are the top 13 hottest years ever recorded by humans on planet Earth. Now, is it a coincidence? Is it a coincidence that greenhouse gases are going up and temperatures are going up? Maybe, probably not. And most scientists don't think it's a coincidence. So what I measure, so I'm a heat scientist. I'm a professor of mechanical engineering, but in essence, I study heat. And this is a graph from a publication that I helped co-author a couple of years ago. And what we see here is heat in the oceans. This is a complicated graph, but what I want you to notice is the levels of blue are energy in the ocean, and they are energies at different ocean layers. And this graph goes from 1960 to the year 2020. And so this graph shows, this is research that I performed with some colleagues in Europe and Asia. This graph shows that ocean heat is also rising. And in fact, oceans are what I study mostly. Oceans are important because they absorb about 93% of the global warming heat. So for every 100 units of heat that our greenhouse gases trap, 93 of them end up in the ocean. So if you really want to know global warming, you have to study ocean warming. And that's why ocean warming is so critical to our understanding of the planet. All right. What I'm showing you here are just some news coverage of the study that we came out with in the year 2020. We actually calculated the rate of ocean warming, and it was covered by CNN and the Telegraph and even Fox News and Newsweek. Our oceans are warming at a rate equal to 5 Hiroshima bombs detonated in the oceans every second of every day of every week of every year. That's how much extra heat our greenhouse gases are putting into the ocean. It's an astonishing amount of heat. And then this is the coverage of our paper on NPR with Paul Huttner. I'm going to go back a little bit further in time because I want to put today's climate in context with past climate. This might be the last graph. And so if you are graph phobic, a respite is on the horizon. This is a graph that goes back 400,000 years. So the left-hand side of this graph is 400,000 years ago. The right-hand side of this graph is today. And there are two colored curves on this graph. One is green and one is red. Red is temperatures. So we've recorded temperatures. I'll explain how we recorded the temperatures, but for right now, red is temperatures and the green is greenhouse gases. And what I want you to notice is over Earth's long history, you always get temperature and greenhouse gases to go together. You never see the green curve go up or down without the red or vice versa. We call these two things handcuffed to each other. The temperatures and greenhouse gases move together. They've moved together for hundreds of thousands of years. And so we should expect that as we increase greenhouse gases, we will see a temperature increase. All right, so John, how the heck do you know what's going on 400,000 years ago? We didn't have thermometers, we didn't have computers, we didn't even have climate scientists. Well, we use signals from nature. And there's some photos on this slide, but I want you to just think about your own personal experience. Let's imagine that you go camping in northern Minnesota. And let's imagine that for some unknown reason, while everyone else is enjoying s'mores and enjoying a fire, you decide to dig in the campsite. And you dig down into the ground and you discover crocodile skeletons and palm fronds. What would you conclude? You would conclude that it had been warmer in the location you were digging because there's clues from nature. And we use those types of clues as we stitch together the past climate. And one of the most important clues that we use is ice cores. Here you're seeing a photograph of a scientist with an ice core at the top. It's about a 6-inch diameter cylinder of ice, and scientists dig down into ice sheets. We can go 2 miles down into ice sheets. They pull out the core, and I'm showing a photograph of a meter-long section of a Greenland ice core in the bottom. And you can likely see little rings or little bands. Each of those bands is a year. And just like the years of a tree rings, scientists count back in time on an ice core. And so you can identify the ice that formed 1,000 years ago, 10,000 years ago, 100,000 years ago. When a scientist takes that ice to the laboratory and melts it, little pockets of air are released, and the air got trapped when the snow fell that made the ice. So when you go to the lab and you melt the ice core, you actually release ancient atmosphere. And in addition, by looking at something called the isotopes of the ice, we can tell temperature. So something like an ice core, like you see on the screen, will tell us time, temperature, and greenhouse gas levels. And that's how you get a plot that looks like this. This is an ice core plot. All right, now I want to turn attention to the future. This is what we have experienced today. This is temperatures. Actually, this is from Catherine Hayhoe, as you can see the credit in the bottom right. This is a graph of temperatures over the last 1,000 years. And I've highlighted the part that we're already worried about. This is what's going to happen in our next 80 years. We expect to see a massive temperature rise that has already started. We expect to see a different planet. So what do we see in the United States? I'm showing you a plot of the US temperatures in the year 2012. And I'm moving the my controls around. I don't know if my Zoom controls are bothering people, but I'm trying to move it around to stay out of the way. But these are the temperatures in the US of 2012. And you might remember 2012 was a very hot year with a very severe drought. Every state that you see colored in red had their hottest year ever recorded. Every state that is in orange was simply much above normal temperatures. Do we care about temperatures like we see on this map? Yeah, we do. This is the US Drought Monitor map in July of 2012. This drought, which is colored by reds and oranges and maroons, shows the severity of drought. And you can see very, very severe, and in fact, it's described as exceptional drought in the center part of the US. This drought that you see on my slide cost our country $35 billion in lost agricultural productivity. So climate change, yeah, it is about polar bears. Yes, it is about whales and sea life, but it's also about our economy and our own well-being. One of the things that we expect to see with climate change, and we are seeing with climate change, is weather is becoming more wild. We think of it as weather on steroids. So something very interesting happened following 2012, and that is we got incredible rain. So this is a rain image of a rain map of February through April 2013. And you can see Minnesota, Wisconsin, Michigan, Illinois, Iowa are blue and purple. They had tremendous rainfall in the early part of 2013. That killed the drought in those regions. But look at California and the West Coast. They went into an exceptionally dry period. And look at what happened to the drought monitor just 2 years after that rainfall. The drought shifted from the center part of the US to the western part of the US. This drought in California was the worst drought in over 1,000 years, and it cost us $4 billion just in agricultural losses to California. So when we think about climate change, we don't think it's always going to be warm, it's always going to be cold, it's always going to be wet, or it's always going to be dry. We are acknowledging that there are bigger swings from one extreme to the other. And that is causing problems both in our country, but also around the world. This is an image that shows the change of very intense rainfall. These are if you think about the 1% heaviest rainfalls, think about all the rainstorms you go through, pick the 1% that is heaviest. Have those changed over time? Well, yes, they have. If you're on the East Coast, those heaviest of all rainfalls have increased 55%. In Minnesota and the Midwest, those heaviest rainfalls have increased 42%. So what this means is we are getting more flooding, more intense precipitation, and that, of course, causes economic consequences as well. So Climate change is not just a steady, slow warming of the climate. It's a wilder weather that's causing economic and social consequences. What is Minnesota going to look like? Well, we actually can map this out, and it depends on what we do with our emissions, but this is a map that shows how temperatures are going to change depending on our scenarios. Scenarios mean, what do humans do? Do humans take action and reduce climate change? That would put you in the left-hand column. Are humans going to ignore climate change and pursue business as usual? That puts you in the right-hand column. So I want you to look at the lower right. That is the picture of what is going to happen by the year by the late 21st century, if humans do not take action. On the other hand, the lower left image shows what happens if we do take action. So what humans do matters. We want to be in the lower scenarios, not the higher scenarios. We actually are the biggest uncertainty and the biggest control of our climate. And for some reason, I have a pointer, which I have to get rid of. I'm going to show just a few more slides of how climate change is impacting the weather. This is a ocean temperature image of the southern part of the US. You should be able to see the Gulf of Mexico. Any area that is red or orange or yellow was hotter than normal. Any area that was blue is colder than normal. Warm oceans fuel storms, and they provide the strength to not only heavy rainfalls, but also hurricanes and major tropical storms. What was happening on October 8th, 2018? Well, you might remember a hurricane. And that year we had 4 major hurricanes. One hurricane was barreling through the Gulf of Mexico over that warm water. And this is a photograph that shows before and after images, I believe, of the Louisiana area after this hurricane hit. But remember, there were 4 major hurricanes that hit the US that year. Hurricanes are becoming stronger because of climate change, because we are warming the ocean that fuels the hurricanes. I'm going to briefly touch on some other economic consequences. This is a graph of billion-dollar weather-related disasters from 1980 to 2020, and these are all adjusted for inflation. What do you see? You see that there is a significant increase of weather-related financial disasters in the US. Last year, it was nearly $400 billion. And in all 3 other years, we nearly hit $300 billion. And many years were over $200 billion. So if anyone tells you climate change is something that doesn't cost money and we can ignore, this is the graph that proves that a lie. So climate-related costs are increasing. And this is just an image that I'm going to get through quick, but this is a NOAA. NOAA is National Oceanic and Atmospheric Administration. And this is just a map of different billion-dollar weather disasters that hit just in the year 2020. I'm going to talk briefly about ice and sea level rise. The image on the left is an image with a white area that shows Arctic ice, so that's near the North Pole, in approximately the year 1980. Every area that you see in white was summer ice that was existing in the year 1980. You might be able to identify Greenland. Greenland is where my cursor is. This area is Canada, and then we have Russia on the other side. The ice of 1980 in the Arctic was equal in space or in area to the continental United States minus Arizona. And I'm using the US just to provide some context for ice. By the year 2005, this is how much we had lost. And when you think about it in the context of the United States, it's pretty remarkable. By the year 2007, we lost that much. And since then, we've lost the equivalent of Texas. So we are losing Arctic ice at a tremendous rate. And that, of course, has consequences to biodiversity in the Arctic, but also sea level rise and so forth. This is a photograph of some scientists on Greenland, which is an ice sheet. And you can, I hope, notice there's a river of water. That river of water is flowing toward the photographer and actually disappears into a hole in the ice. These are called moulins. It's a French word, M-O-U-L-I-N, and it is a river of water that is formed. I mean, ice is melting so rapidly that we're getting rivers of water that carry water off of ice sheets. This looks like a lake. You can see a motorboat, but in the background, you can see an ice sheet. This is a lake on top of an ice sheet. I'm going to briefly touch on the other part of the, I'm going to briefly touch on the other pole. I'm showing you an image of Antarctica, and I've called out what's called the Larsen B ice shelf, which is off a tongue off of West Africa. In a period of a month and a half, something incredible happened. This is a satellite image of the Larsen B ice shelf. You might be able to notice some small blackish dots on the ice. Those are moulins. Those are melt ponds. This is a photograph February. Here's March 5th and March 7th. In the time of a month and a half, an ice sheet the size of Rhode Island collapsed and flowed into the ocean. Since then, we've lost other ice shelves. This is the Wilkins ice shelf, which broke off in 2009. And in 2017, we lost the Larsen C ice shelf. And so we are losing ice in both the poles, the North Pole and the South Pole, but we're also losing glaciers. So glaciers are ice that is present on the top of mountains where it's cold. I'm showing you two images. The bottom image is the McCarty Glacier in Alaska, taken in 1909, and you can see the glacier there. And the top photo is in 2004, camera positioned in the same location. The glacier's gone. And in fact, if you have traveled to Glacier National Park or other areas where there are glaciers, you know about the recession of glaciers and our loss of glacier ice. I'm showing you two more photographs. The bottom one is the Muir and Riggs Glacier in 1941, and the top image is more recently in 2004. Again, we're losing glaciers at a rapid pace. Now, in the US, we may not care that much about glaciers, but if you rely upon glaciers for your drinking water, like the Indian subcontinent, you are very concerned about glacier loss and how that's affecting availability of water. Just a couple more images, and then we'll get to some solutions and I'll wrap up. This is a satellite photograph, very recent. This is February 2020. This is last year. Temperatures, and these are photographs of an island off of the Antarctica, South Pole, and we can see melt ponds. In the left-hand satellite photograph, there are no melt ponds, February 4th. By the time we get just 9 days later, we have melt ponds sitting atop a mountain in Antarctica. 64.9 degrees Fahrenheit was reached. Unbelievable temperatures for this part of the planet. Why do we care about ice? Because as ice melts, sea level rises. I'm showing a topological map of Bangladesh on the right, and then a zoomed out image of Southeast Asia. And what the colors that you see denote height above sea level. And what you can see is huge portions of Bangladesh are very, very close to sea level, within a few meters. And there are other locations in Southeast Asia that are likewise close to sea level rise, or close to current sea level. Scientists expect approximately 3 feet or 1 meter of sea level rise by the year 2100, which is enough to displace 20 million people from Bangladesh and 150 million people worldwide. Now think about that. The United States had trouble dealing with climate refugees or refugees from Katrina. That wasn't that long ago. What, a couple 100,000 people from Katrina? Richest country in the world? What do you do if you're Bangladesh? What do you do if you're India and you have 20 million climate refugees? Think about the social and economic and even national security threats that this type of problem poses to the world. I'm going to bring this close to home. This is a map of the U.S. with 1 meter of sea level rise. And already southern Florida, parts of the Carolinas and New Orleans have disappeared. This is 3 meters of sea level rise. You've lost Miami. And of course, New Orleans is further underwater. And then this is 6 meters of sea level rise. Think about the cost of relocating Miami. Think about the cost of relocating New Orleans or the Carolina coast. Could we have this much sea level rise? Well, if we lose Greenland, which sometimes scientists think we will lose, just Greenland itself is 7 meters, just Greenland. The other part of the planet that scientists are very worried about is West Antarctica. That's unstable, and that's another 5 meters. So between West Antarctica and Greenland, you have 40 feet of sea level rise. And if all of Antarctica were to melt, you'd have 270 feet. I mean, these are stunning numbers. And it speaks to us, telling us we've got to take action now to avoid this kind of sea level rise. There are some other things that climate change will lead to, and this is the most depressing slide because this is the end of the bad news. I promise we'll get to some good news. Climate change, the things that I'm concerned about are lower crop yields, especially subsistence farming areas, ocean acidification. We're actually changing our oceans into a carbonated beverage. You think about it, if you take a soda and you shake it and open the top, there's a fizzing, that's carbon dioxide coming out of the water. We have so much carbon dioxide in the atmosphere, it's being absorbed into the ocean, and that makes it hard for shell-forming creatures to keep their shells. With respect to rainfall, the general rule of thumb is areas that are currently dry are going to become drier. Areas that are currently wet will become wetter. There'll be more extreme weather events, hurricanes, invasive species, et cetera, et cetera. Now, this is depressing. Let's throw up our hands, right, and give up? Not at all. How do we move forward? We move forward by targeting our solutions to be effective. So this is, I promise, the last graph you will ever see from me, at least today. This is a graph that shows the projected increase of carbon from now out to 2050. There is no silver buckshot. There's no magic pixie dust that we can use, but there is silver buckshot. There's a lot of things that we can do together that adds up. And if we do these things collectively, we can really dent and reduce our emissions. One of the things I'm most excited about is this is a really, really busy plot, but it shows the cost. The numbers I've just circled are the costs of energy obtained by different fossil fuels, and the cost of wind and solar are competitive. You can get electricity from wind and solar at about the same price as fossil fuels. So it makes sense economically as well as from an environmental standpoint. Change is possible. This is another Katharine Hayhoe photograph. I love the one on the left. It's a rusty oil well in the foreground and beautiful turbines in the background generating money and energy for the person who's put those up. We have an entrepreneur on the right-hand side who's showing his algae-based biofuel. That's algae that sucks carbon dioxide out of the air, and then you can run a car with it. So change is possible. I've got 2 more slides, and this slide, I'll be honest with you, I'm a scientist, and you may not recognize it or you may not believe it, but I'm a human. And I have daughters, and I have people I care about, and I'm showing some photos of, this is Lily, she's my wild child. And this is my redhead, Olivia. She's my oldest. And I want my daughters to have a beautiful planet like I had and have a high quality of living like I've had on this beautiful planet. And I have been fortunate enough to not only have these daughters, but be able to explore some of the most precious places on our planet and see the wonderful diversity that we have. Now, this is a photograph of my 3rd daughter in her homeland of Uganda. This is Avery. She's now a Minnesotan, but she was adopted from Uganda, which is one of the countries being hit most significantly by climate change. And this is my last daughter, Neve, who is also adopted, and she is of Samoan descent and Puerto Rican descent. And I want, my daughters are going to ask me one of 2 questions. They're going to say, Dad, you knew what was going on. Why didn't you do something about it? Or they're going to ask me, and by the way, these are all photographs that I've been fortunate enough to take with my own camera. So I really treasure the kind of wildlife that we have on this planet. The other question, the one I really want them to ask is, Dad, how did your generation have the uncommon courage to take action to preserve this planet for us? I desperately want my daughters to ask me that second question, and that's why I'm honored, and it's a privilege to be able to give this talk to you today. And I'm going to leave you with 4 ideas. You've seen a lot of graphs, you've heard a lot of numbers. These are the things I want you to know. 1, scientists know. We've actually known about global warming for over 150 years. The first scientific studies of global warming and greenhouse gases was in the 1800s. This is not something Al Gore invented. This is not something that was just discovered a few years ago. We've known it for a long time. We can solve this problem today with today's technology. We don't need to wait for new technology. We can do it right now. If we are smart about our solutions, we can not only help the environment, but we can create jobs, generate energy, and improve national security. I want to pay farmers in Minnesota for wind turbine power, and I want to pay Minnesotan engineers to install solar panels. I don't want to have to pay to import energy from countries that don't like us so much. And lastly, my last takeaway message is, don't let anyone tell you it's too expensive to do something about climate change. As we've seen today, it's too expensive to do nothing. Doing nothing is a choice, and it has tremendous consequences. And with that, I'm going to turn this back. I don't know how to give up share, actually. Oh, stop share. I'm going to turn this back to our moderator, Jeff Jalkio, and open the floor for questions.
Oh, thank you, John. And I'm looking at the questions in this first one. You may have to explain the question in addition to answering it. The question is, in what year did you realize anthropogenic climate change was definitely happening? What tipped the balance to make you know for sure? When did this realization happen for you? And what's your favorite estimate of equilibrium climate sensitivity?
Oh my gosh. Okay, that's a number of questions. I can answer. The first group of questions was around 2005 to 2007. I mean, I always trusted the scientists. So when they said climate change was happening, I trusted them. But I began to do my own research around 2007. And I began working with NOAA to measure ocean temperatures around 2010. So I'd say it's circa 2005. And my best estimate of climate sensitivity, first of all, what is climate sensitivity? It is how fast will or how much will the Earth's temperature change if we increase emissions. And the best estimates are, if we double the amount of greenhouse gases in the atmosphere, we'll see approximately a 2 to 3 degrees Celsius or a 4 to 5 degree Fahrenheit average temperature range. Now that, by the way, that doesn't sound like much. It doesn't sound like much, but on average, that's day and night year round. That's an enormous, enormous temperature change. So approximately 2 to 3 Celsius.
Thank you. The next question is, thinking about those RCP scenarios, which of those scenarios do you believe humans are moving towards currently? And are more recent efforts actually moving us towards one of the lower scenarios?
That's a great question. And before I answer the question, I recognize there won't be time for everyone to get their questions answered. I would encourage anyone to email me at any time with questions. If you don't get them answered, or if you hear something in the future, feel free to bother me with emails. I'm happy to answer questions. The question, what was the question, Jeff? I forgot it. RCP scenarios. So RCP just stands for emission scenarios. And we are currently on a business as usual worst case scenario. However, we have put in action significant plans that will bring us toward one of the lower scenarios. So I would say we're about, if things keep going the way they're going, we're going to be about 2/3 of the way toward the worst case. But things can change. And in fact, Biden announced just today that the US plans to half emissions by approximately 2030. So things can change very, very rapidly, but and we are bringing the curve down. We just need to continue to bring it down.
Okay. We have another question where you may need to explain the background also. The question is, where and why do you differ with Richard Lindzen?
Richard Lindzen is he's a climate scientist, and he is one of this very small minority of climate scientists who doesn't think, who knows climate change is happening and caused by humans. He just doesn't think that it's going to be a severe problem. And Richard Lindzen had a hypothesis that has now been shown to be incorrect. And his hypothesis was that as the Earth warms and there's more humidity in the atmosphere, that will increase cloud cover, which will then cool the planet. So his thesis was that there would be a cooling effect caused by more humidity in the air. And that has been shown to be incorrect. And so I disagree with him.
Okay. And I think this next question is actually addressed to both you and Alan. So hopefully Alan is still with us. And the question is,
still here.
With the limited capacity of humans to cooperate globally, the high levels of conflict among people and the fierce opposition of the US to doing anything about climate change, mitigation could go badly, tardily, and with minimal effect. How are our speakers preparing their children and grandchildren for the different planet that Professor Abraham projects? How should we be preparing our children and grandchildren for a different planet?
Alan, if it's okay, could I answer this first and then kick it to you? So we have long passed the time when we can stop climate change. Climate change is happening, and it's going to continue to happen. The Earth's climate is like a heavy locomotive. You can't just slam on the brakes and stop it. It's a really unique problem, and it's been complicated by the fact that things we do now will only affect things 10, 20, 30 years from now. So we've lost the window to stop it, but we absolutely can slow things down. But because we can't stop it, we're going to have to do two things. We're going to have to adapt and mitigate. Mitigate means reduce emissions and make the problem less bad. Adapt means adapt our infrastructure so that we are less susceptible to climate change. So we need to do both things. And I tell people, including my family members, to be prepared to adapt and mitigate. Now, I will say this, that in Minnesota, we are living in one of the locations that will be least affected by climate change, least affected in the negative consequences. We will have negative consequences, but we are in one of those spots that is going to fare much better than others. But my children understand the importance of climate change, and they are already anticipating the need to adapt and mitigate. And Alan, I'll turn it over to you for more.
No, I thought that was a brilliant response. And I guess I would only say that really the concern has to be, how do we as a planet, as the whole planet, begin moving toward this? And one of the bright spots, I think, is as humans begin to recognize the immediacy of this problem and how it's affecting not just their children and grandchildren, them, then they tend to get more serious. So, I mean, even a country like China, which has long been a significant polluter as it tried to ramp itself up, to be a greater economic powerhouse for its own geopolitical concerns, they are starting to realize that, they're going to have to do something. India has been long realized they're going to have to do something. America is starting to realize that. And sure, there will always be, a number of curmudgeons that won't get involved, but you don't need absolutely every human.
Right.
You just need the major power structures and political structures to start making realistic and doable. I mean, that's one of the things you said, John. It's absolutely right. We have the technology. We can make a lot of these adaptations now to mitigate our emissions. It's just a matter of us all taking it seriously and making it a high priority. And I think as we continue to see these horrible hurricanes, as we continue to see these droughts, as we continue to see areas of the planet directly affected by climate change, the human race is going to go, oh my gosh, this is serious, we better do something. And my hope is that we're going to continue to bring that curve down, as you just said. It's a hope. I mean, but I think that we do have some reason for hope. It's not a terrible, horrible, oh my gosh, in 20 years the whole planet will be dead. I don't see reason for that kind of pessimism. I think that things will change for the worse, but we might be able to accelerate the kinds of behaviors, rules, and principles and that mitigate the damage in the long run.
And if I could just add something, Alan, the thing that makes me, and it's going to piggyback on what you say, the thing that makes me most optimistic is in the past, it used to be a personal virtue that would make you be green. And now it's an economic advantage as well. I mean, I've been buying wind power for my house for about 20 years. You can do that with Excel's wind source program. And it costs about 50 cents or $1 more per month to have total wind power. I mean, that's eliminating one of your biggest sources of emission. Last year, 2 years ago, I put solar panels on my house. The return on investment's about 8 years. So in the summer, I get paid for energy. And after 8 years, it is pure profit. So when you can have solutions that will save people money and save the environment, who can be against that? And that's what I'm most optimistic. I actually think we've passed a tipping point in the economics of sustainable energy. And I'm extraordinarily optimistic about that.
Well, I think that's a wonderfully optimistic note to end on this evening. I want to respect the published agenda for tonight and get folks home on time. So I would really like to thank you all for taking the time to join us in tonight's event. And I'd invite you all to please join me in thanking our speakers for their participation. You can leave comments in the chat for them. And as John said, I think they would both welcome any additional questions afterwards via email. So thank you again, and good night.
Thank you. Good night. It's been great.